Hi, welcome to today's lesson. Today we're going to be looking at the reason for factorizing. Okay, we're going to be using factorizing to simplify fractions. Okay, so this I've called factorizing to cancel. Okay, so factorizing to cancel, and let's just dive into the examples of this. So e.g., by the way, you need to have seen factorizing out a common factor, factorizing out factorizing quadratics, all right, in order to keep up with this. Okay, so let's take a look at the first one. 4p plus 6pq, pq, all divided by 2p. All right, now, it is very tempting, and I've seen people do this. They go, oh, 2 into 4 goes twice, p into p goes z, I'm left with 2 plus 6pq. No. Okay, you must remember, okay, that I can only factorize if I have one term on top and one term at the bottom. Right now, I've got two terms on top. Okay, this is quite important. I can only factorize if there's one term on top. So how do I make two terms into one term, right? I use the idea that multiplication joins terms, all right? So what I'm going to do is I'm going to factorize this to turn it into a multiplication. Okay, so the first thing I'm going to do is I'm going to take out a common factor on top. So what's the common factor of the number part? The common factor of the number part is 2, right? What's the common factor of the letter part? P. Okay, so that's what's on top. Now, here, if I take a 2 out of 4, I'm left with 2. If I take a p out of p, I've got no p's left. I pulled it out. He's in front now. So plus, same sign. If I take a 2 out of 6, I'm left with 3. If I take a p out of pq, I'm just left with q. So that's the top factorized, all over 2p. There's nothing to do at the bottom. All right. Now I can say, okay, great. Now I've got one term on top. Multiplication, here, this is multiplication, joins terms. This is acting as one term, that's acting as one term. Now that I have one term on top, one term at the bottom, now I can cancel. Well, 2 goes into 2 once, p goes into p once. What's left over? Just that. Okay? So the simplification of this is 2 plus 3q. Done. All right. Cool. Let's do another one. All right. So, similar idea. So let's do e.g. 2. 5x minus 10, 5x minus 10, all divided by x minus 2. Okay, stop. There on top is two terms. Okay, this is actually two terms as well, but I'll show you a way of thinking of it to make it one term. Okay, so let's first jump in and say, okay, well, what can we take out at the top? Well, there's a 5 and there's a 5. So let's pull out a common factor of a 5, and what am I left with? 5 divided by 5 is 1, so I'm left with 1x. 10 divided by 5 is 2. All over. Now here's the thing where I can turn this two terms into one term. I can take out a common factor of 1. That's one way to think of it. If I pull 1 out of x, I'm left with 1x. If I put 1 out of negative 2, I'm left with negative 2. So I can do that. There would be a way of thinking of it is there's an invisible 1 there. I don't need to write it because 1 times anything is itself. But this is the way of thinking of turning a bracket straight into a single term, if needs be. Are you with me? Okay, fantastic. So now I can just cancel. Well, I've got one term on top, and I've got one term at the bottom, so this whole thing can cancel that whole thing. It's the same. Bracket divided by bracket, the same divided by the same is 1. That's why you can do it. All right. So I'm left with, what's left over? Just 5. So this simplifies into just 5. Are you with me with that? Okay, right, so let's do two more examples. Those are pretty straightforward, taking out a common factor. You just have to be careful. You cannot just cancel straight up, okay? You have to factorize first. So let's look at example 3, e.g. 3, okay? 6x squared plus 3a, a squared plus 3a, all divided by 3a squared. All right, give this a shot. Pause me. No, I'm only joking, I've paused. Pause me and then go and try this out again. Right, so, sorry, sometimes I'm so corny. let's pull out a common factor here. The common factor from the number part is 3, okay? The common factor from the letter part, remember if you watch factorization, the common factor is the lowest power of whatever variable they have in common. It's a mouthful, but it helps remember that. So lowest power is a, so there's just one a there. So what am I left with? If I pull a 3 out of 6, 6 divided by 3 is 2. If I pull an a out of a squared, I'm left with a. Same sign, plus. Well, now this is the thing that catches people. You'll be surprised how often this catches people. If I pull a 3a out of 3a, well, what am I left with? Nothing. This is not just taking it out. It's not taking away. Maybe pulling out is the wrong word to use. If I divide out 3a, well, 3 divided by 3 is 1. A divided by a is 1. So what am I left with? I'm left with the 1 all over 3a squared. Okay, so now we can cancel, right? Well, 3 cancel with 3. A squared, there's 2 a's here, cancel with a, and so I'm just left with an a. Alright, so my final answer with this is 2a plus 1 all over one of the a's left underneath there. I've seen people do this. I've seen people then go 2a plus 1 over a, and they do this. And they ref, 2 plus 1 is 3. No, N-O-E, no, please. I cannot, this is what I'm talking about by factors on top of factors, one term on top and one term on bottom. There is now 2 terms on top. I cannot divide this into those 2. Alright? Okay, there is a way that you can simplify this slightly. Alright, but it's not worth it because you end up with 1 over a as another fraction. You get 2 plus 1 over a. Okay, if you wanted to split that denominator. But please, you cannot cancel it. If there's 2 terms on top, I can't just cancel like that. Okay, last question. And I want a little bit more space for this last question. Okay, so I'm taking this off. You should be okay with that. The last question I'm going to put over here. Right, so e.g. 4. Okay, so this is where you're getting to. This is where you've got to be comfortable with doing. X squared plus 5x plus 6 over x squared plus 3x. Okay, so now we're here, and we say, great. Oh, please, I've seen people do this. I'm going to mess up my writing for a second, just to prove a point quickly. I've seen people do this. That cancel with that cancel with that. 3 goes into 6, 2, and they're left with 7. 0, nothing, no marks. Okay, the answer to this is not 7. Okay, you cannot do that. Alright, I don't mind working and rubbing it out just to show you that you cannot do that. Please do not do that. I got x squared plus 5x plus 6 all over x squared plus 3x. Wait, this board is getting dirty now. Alright, but I can't just straightforward cancel like that. You have to factorize first, because right now I've got 3 terms on top and 2 terms at the bottom. I need 1 term on top, 1 term at the bottom. And the way that I do that is I use factorization. So factors of 6 that give me 5, okay, x2, x3. Alright, go check this. I've done this work before. So you can go and check this with the factorization tree that you should have seen with factorizing quadratics. Okay, so the signs are the same. The sign says they both have to be positive, positive, positive. And then I can take out a common factor here. The common factor, well, there's no numerical factor because that's 1 and that's 3. The algebraic factor, the variable factor, is lowest power x. So I can pull out an x. And I'm left with, pull out an x out of there, x plus 3. Alright? And now you should all be screaming, oh, wow, you can cancel brackets, you can cancel brackets. Yes. Now I can cancel because now I have 1 term on top and 1 term at the bottom. Multiplication makes things 1 term. So this cancels with this. Now you can cancel. And what we're left with is x plus 2 all over x. Again, I cannot do anything more to this. These x's there cannot cancel. Alright? Not unless you split that denominator, which is, if you want to, you can. It's quite advanced to do. You use it as a trick in differentiation a little bit later. And unless you split that denominator, you cannot simplify this any further. Alrighty, that's the answer. Okay, and GCSE up to year 11, alright, that's the answer. Okay, alright. Not too bad. You have to be good at factorizing. This is why we do factorizing. Okay, just remember, You cannot cancel up here. You have to factorize it first. I don't know how many times I've said it. I've lost track. Okay, go watch it again so you can hear it some more. Okay, remember, I'm here for you.